abundance was highest. Transect 2, that's this one up here, you had an inverse relationship. So as you're heading out to the edge of the reef, you had a real increase in algal diversity around here, and then it starts to decrease as you get further out. And then you had, of course, less sediment coverage because of the coral cover, but you had an inverse relationship between Calcarina hispida and Bacillogipsina. That Bacillogipsina was really happy as it got further and further out to the reef edge. And then finally, Transect 3 over here, you have a weaker inverse relationship between the sediment coverage and the algal diversity. All right, so if you applied clusters again, because I'm such a fan of Bray-Curtis cluster analysis, you get nice assemblages. You've got one big assemblage 1. I called this originally a sub-assemblage, but now I'm kind of thinking it might be an assemblage enough on its own. Assemblage 2, and then unfortunately, I don't think I can really call this assemblage 3 on its own because it's only one sample. But anyway, it's quite different, which you'll find out. And these pop out with MDS analysis as well. If you look at Fisher alpha, you can see that as you go up in assemblages, you've got increased number of species, increased richness, and also increased evenness. So you have less dominance by 1 or 2 species as you go up in assemblage number. And then if you plot them all, it's very exciting because your assemblages all zone really nicely on the reefs. The lines that are going, the non-fully coloured bits, are because the Marine Parks Authority wouldn't let me sample. So I've had to infer that that those areas are the same as where I did get samples. So assemblage 1 is this blue area, which is all in the lower areas of the reef flat. This is Heron. That's where I took my transects. Sykes Reef, this is Wistari. It's around this area here. And this is One Tree Reef. Assemblage 2 is all within the lagoons of the reefs that had lagoons. And then assemblage 3 is just this little dude in the channel on its own. And these little circles are all grain size, so it's just to show that, so this blue colour is the 60 micron range. It's just to show that the lagoonal assemblages had a finer grain size than the reef flats. So to quickly, okay, almost done, I promise. So quickly run through, we've got a high energy environment on the reef flat dominated by rapid growing symbiont-bearing taxa. There was an average diversity of only 22 species per sample. Fisher alpha set a shelf hypersaline lagoon. There was clear dominance by 1 or 2 species, and there were very few live specimens. Assemblage 1A was the exact, oh, I didn't show you where assemblage 1A was, duh. So this is assemblage 1A here on the reef of the edge of the reef, and then again here and here on the edge of these 2 lagoons. So assemblage 1A is basically the same dominant taxa, but their abundance was different. It had more species and it indicated a marine lagoon, and Shannon and Wiener reflected a more even spread. Assemblage 2 was a lagoon environment. You can see these, I didn't explain this, sorry. So these are all the dominant taxa in order of abundance. So assemblage 2, you've got a completely different suite of forams. It's low energy, below tidal range, finer sediments dominated by small heterotrophic taxa, 42 species per site on average, high species richness, a more even spread of taxa, and hosted a lot of live specimens. Finally, that one interreef channel had a completely different suite of foraminifera once again, lower energy than assemblage 1, but not as much as assemblage 2. It was deeper, a broader range of sands dominated by large heterotrophic species and small opportunistic species, a high proportion of big forams, lower benthic foraminifera, larger benthic foraminifera. So what they're doing is they're making a really big test because they've got symbionts that are helping them grow, and because they're in that slightly lower energy environment, they could afford to grow a much bigger test that was more fragile because they weren't getting moved around as much. Very rich with Fisher alpha and had a pretty good even spread of species to species evenness. So 3 distinct assemblages and 1 sub-assemblage. You've got dominant physical parameters that were determining where your forams were found, including water depth, energy regime, available substrate, grain size, and proportion of macroalgal versus sediment cover. And thanks to all these people and all these different institutions that were involved in all this work, particularly DAMSTEC and JSPS for letting me come here. And are there any questions? That's it. You're free.